All right, we've got the Unity test coming up soon. These questions are very similar to what you'd see on the test, so it'd be great if you could do them on your own, but I think a number of you are still struggling with some of these ideas, so we'll go ahead and work through them together. Pause and work ahead and maybe check your answer if you want. That'd be a great way to do this, but let's go ahead and get started. So number 1 says, use the graph below to identify the following features of the quadratic function. So do we have a minimum or a maximum value? Well, maximum means that it doesn't go any taller. So we've got a point and there is nothing above that point on the graph. There are no points on the parabola above that, so this is a maximum value. And if we zoom in, we see that it has a maximum value is always the y. So our maximum value is going to be when y equals 4. So we have a maximum value of 4. Maximum at, that's the at sign, a maximum at 4. Axis of symmetry, the axis of symmetry is going to always be an x equals line for our parabolas. And we're going to see where does it get split down the middle. It goes through the vertex. It's the x equals line through the vertex, so in this case it is x equals 0. So our axis of symmetry is x equals 0. The domain for all of these the domain is the x values, so we need to be able to remember that. Our possible x values. And for all the parabolas, it goes from negative infinity to positive infinity. But our range is a little bit different. The range is our y values. And because we have a maximum y value, we can't go any above that. So if we look over here at our graph, we can see our y values stop here, but they go on and on and on in that direction, which would be negative infinity. So the negative should come first. The range is negative infinity to positive 4. If you need to pause to get those filled in, go ahead and do that now. All right, number 2, the word that best completes the following statement within the domain negative infinity to 0, and let's highlight this. So this domain, let's put it in. So x is negative infinity way over here, and it said what is happening with x, or what is happening with the function as we go to 0. So in that kind of purple-pink highlighted area, are the y values increasing or decreasing? So I'm going to start over here where my y value is way low, and what's happening to my y? The y numbers are going up and up and up and up. So since the y values are going up, we say that it is increasing. The parabola is increasing. Alright, we did something I think similar to this on the first day's notes. So this all relates to our vertex form, which is, for number 3, is y equals a times x minus h squared plus k. And this a value so when a is negative, it's going to be a rhox. When a, and let's just call it a fraction, although that's not the best way to think of it. When a is, that word is fraction. When a is a fraction, it gets wider. It has a vertical shrink, which makes it look wider. And when a is bigger than 1, let's say this, when the absolute value of A is bigger than 1, then it looks narrower. It looks narrower. Boy, that's terrible handwriting. Sorry about that. The H is a little bit easier. So if this is our H, when it's X minus a number, it's a right shift. When it's X plus a number, it's a left shift. And the K is the easiest one. You can memorize it. When it's plus K, it's a up shift. When it's minus K, it's a down shift. So let's look at what we got. Number 1, our A value is 1. There is no parentheses, so our H value is 0. All we have is this plus 8. And when we have a plus 8 outside, it's going to be our K value, so it's a shift up. All we have is a shift up. And that looks like G. We look at number 2. We have something in the parentheses. We have an X minus 9 in parentheses. So X minus 9 is our H value. So we look over at the blue. When it's minus a number, it's a right shift. So we're going to find where it says shifted right. That looks like I. Number 3, it's plus 2 inside. When it says X plus, it's actually a left shift. And that looks like H. Now, the next one has 2 transformations. It's got a minus out front, and it's got a plus 3 in back. So the minus is A equals negative, that's a rocks. So we're going to have a reflection over the x-axis, and we're going to have a shifted up. It looks like F. On number 5, we have all we have is an A value. It's positive and it's 4. So when the absolute value of A is bigger than 1, it's narrower. And we're going to find the word narrower. I think that's letter E. 1/5 X, again, that's just our A value. It's a fraction, or it's better to think of it, it's between -1 and +1. The fraction is going to make it look wider, although it's actually a vertical shrink. Now this last one, or this next one, number 7, has a lot. It's got an A value. It has a H value. And it has K value. So the 2 is going to make it narrow. What those hieroglyphics say. That -3 is going to make it go right. Right, and the +1 is going to make it go up. I don't think I can read any of that. So we're looking at something that's narrow, right, and up, and it looks like that's C. Number 8, it just has the negative. That's a reflection of the x-axis. And 9, we've got quite a few again. So we've got our A value, or start from the beginning. A value of 1/5. We've got our B value of +3, and our K value. So our H value is has a +3 with it. Our K value is -4. So the 1/5 makes it wider. Let's do this better. So it's going to be wide. It's going to be left because of the +3, and it's going to be down because of the -4. So wide, left, and down is J. If you need to pause and review that, go ahead and pause it. And let's go on to the next one. Alright, we're going to want to match the following quadratic functions to the graph. So, I think we can do this hopefully by just looking for our vertex and knowing whether it goes up or down. So if we look at the a values, we know the x value of the vertex is, we should probably write this somewhere where we can see it over and over. The x value of the vertex is opposite of b over 2a. And remember, these are in the form ax squared plus bx plus c. So for the first one, let's just find all these at once. The first one, our a value is -1. A equals -1. Our b value is 14. So the opposite of b over a is -14 2a over -2, which is 7. So we're looking for something that has an x value of the vertex at 7. And as I scroll around, there's only one of them. So that's the first one. Let's look at the b. So our a value again is -1. Our b value is 6. Opposite of b over 2a gives us -6 over -2, which is 3. We're looking for something that has an x vertex at 3. So 1, 2, 3. 1, 2, 3. This one seems to have, sorry about that. Alright. I'll use the highlighter. This to me looks like the x vertex is at 3. That one, I think so. Now this one seems a little weird. Let's look at this one more closely. To me, the 3 is right here, so it's not quite at 3, and it's not quite at 2. This one sure looks like it's going to be at 2.5. That doesn't meet our criteria. I think we're down to this one. So this is graph B. Let's look at C. Opposite of B is opposite of -10 over 2a is 2 times 2. So 10 over 4, which is 2.5. It seems like we found that one, didn't we? So the x value of the vertex is going to be 2.5. It looks like it's right there. We could find the y value, and that would be a fraction as well. You also notice that it's going up, the u is going up, and that it's a little narrower, and that too is what makes it narrower. We have time for one more before the video is going to cut out. Opposite of b over 2a is going to be the opposite of -10 over 2 times 1, which is 10 over 2, which is 5. So we're looking for a graph that has an x vertex at 5. And it looks to me this one is at 5. And that's the only one at 5. So there's your D. And I'll see you in the next video.